This lesson is over how to solve inequalities. So David bought a shirt for $8 and some pants for X dollar. He spent at most $19. Which inequality would you use from these options? Less than or equal to, less than, greater than, or greater than and equal to. So which one would you use? So he spent at most $19. What does that mean to you? Give me some examples. I would say $15. I would say $10. I would say $18.50. What about $19? That would work. So all the numbers I said were equal to $19, so it's going to be one of these two. And then the other numbers I said were less than, so it would be this one. In case you are wondering why I chose that one, because I do have some students who look at this and are getting confused. This side is less than this side, so 8 plus x is less than or equal to $19. And if you solve this, which we will solve in our subsequent subsequent slides, you will know what the most he can spend on pants. So let's solve this. We're solving for x. We need to isolate x. So what do you know on how to solve this? What is the inverse of 8? Minus 8. Balance it on the other side. This cancel. So this is going to be 11. X has to be less than or equal to $11. That means he can buy a pants for $10. 8 plus $10, that's $18. He'll still spend less than $19. What he could buy a pants exactly $11. 8 plus 11 is $19. It could be less or equal to $19 because the most he can spend is $19 on the pants and shirt. So let's look at this. In this one, I will assign different variables, different numbers to different students, and they would decide if their inequality is true or false. For example, if I assign an inequality of 10 to a student, they'll add 10 to 4 and get 14. Is that less than 7? They'll say false. So let's pretend I assign -5. -5 plus 4 is -1. Is that less than 7? True. -4 plus 4 is 0. Less than 7? True. -3 plus 4 is 1. Less than 7? True. -2 plus 4 is 2. Less than 7? True. -1 plus 4 is 3. Less than 7? True. 0 plus 4, less than 7? True. 1 plus 4 is 5. Less than 7? True. 2 plus 4 is 6. Less than 7? True. 3 plus 4 is 7. Is that less than 7? False. That's actually equal. 4 plus 4 is 8, less than 7. False. 5 plus 4 is 9. Is 9 less than 7? False. So true, 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 true. Cancel, cancel, cancel. Some people like using different options, like they guess and check, guess and check, guess and check. There must be a faster way. How about solving this algebraically? A plus 4 is less than 7. Can I isolate A? Think of it like an equation. Instead of with an equal sign, you're using inequality. Same, bless me. Can you isolate A? So what is the inverse of plus 4? Minus 4. Don't forget the balance on the other side. This cancel. A is less than 3. Let's go back to our number line. A is less than 3. Are all of these numbers I circle, are they all less than 3? Yeah. Oh my God, solving algebraically saves a lot of time. Now let's graph this. If A is less than 3, open dot or close dot? Open dot, because it's not equal to 3, it has to be less than 3. Now shade in everything less than 3. And that is our answer. All right, next one. Here's another table. Yes, we are going to go through each one. So a number A minus 1 has to be greater or equal to 2. Greater or equal to 2. So let's see which one makes sense here. -5 minus 1 is -6. That is not greater than 2. That's false. Negative 4 minus 1 is negative 5. Nope, not greater than 2. Negative 3 minus 1 is negative 4. Nope. Negative 2 minus 1 is negative 3, not greater than 2. Negative 1 minus 1 is negative 2. Nope. 0 minus 1, that is not greater than 2. 1 minus 1 is 0. Nope, not greater than 2. 2 minus 1 is 1, not greater than 2. 3 minus 1 is 2. Is it greater or equal to 2? That's true. 4 minus 1 is 3, which is greater than 2. True and true. So let's scratch out what we need to scratch out. So we know 3, 4, 5 I circle, and all of these are false. Did you like going one by one on a number line and solving it and saying true or false? Or would you like to solve this algebraically? I need to isolate A. So solve for A. Isolate A. What's the inverse of minus 1 plus 1 plus 1? Does cancel? A should be greater or equal to 3. So our answer is this. Let's look at our number line. Is that true? Ooh, all these numbers I circle are equal to 3 or greater than 3. So we did a good job. So is this going to be an open dot or closed dot? Closed dot because we're including 3. It says equal to 3. And let's highlight numbers that are greater than 3, such as 3, 4, 5. Now, what I would like you to do is, without making a table, could you solve this algebraically and save yourself time? So I need to solve each inequality, represent the solution on a number line. I need to isolate A by doing the inverse of plus 5 with minus 5. Minus 5 does cancel. A is going to be less than 6. So here's 6, 7, 8, 5, and 4. Well, A has to be less than 6. Can't equal to 6, so it has to be an open dot. And all of these numbers, such as 5 and 4, are all less than 6. Next one. So G minus 13 and 4/10 has to be greater or equal to 3 and 1/10. I need to isolate G by doing an inverse. So I inverse it. Just cancel. If I add this up, I get G is greater or equal to 16 and 5/10. So this is 16 and 5/10, 16 and 6/10, 16 and 4/10. So it has to be equal, so close dot, and it has to be greater. So greater numbers go this way. Remember, in the number line, it goes from least to greatest. Next one. I need to isolate A. The inverse of plus 7 is minus 7. Minus 7 does cancel. So negative 4 with minus 7 is like saying negative 7. That would be negative 11. So negative 11, negative 10, negative 12 has to be equal to negative 11, but less than it. So it all goes here. All these numbers are less than negative 11 or equal to negative 11. Next one, I need to isolate G. What's the inverse of minus 6? Plus 6. Plus 6 does cancel. Negative 2 with 6 positives would be 4. So here's my number line. G has to be greater than 4. But can it be equal to 3? 4? No. So that's why it has to be an open dot. It is not equal to 4, but it could be equal to 4.1, 4.2, 4.3, equal to 4. And here's our last example. I need to isolate x. So the inverse is minus 4. Minus 4 just cancel. Negative 3 minus 4 is like saying negative 4. That's negative 7. This is okay, but when I like solving inequalities, I like putting the variable on the left side. Let's see. So if I put it on the left side, this smaller is facing x, so should be this way. So x would be less than negative 7. So open dot and facing all the numbers that are less than negative 7. So what we did is we solved algebraically the variable, and then just like an equation, you solve it and then you graph it. If it has an equal sign, it's a closed dot. If it doesn't, it's an open dot. And then you shade either less or greater down here.